Hey guys, I wanted to do a quick video on rhythm recognition and how the waveforms correlate to the conduction pathway. If we remember from our Einthoven's triangle, we can run a line from our SA node through our AV junction, through our left ventricle, and this would be the normal average electrical conduction, or what we call our lead 2 view. So here we have a normal sinus rhythm. It's fairly obvious, but it's a good place to start. So when we start on our journey here for our electrical conduction, we're going to start at the SA node. And this is where I like to begin for my rhythm recognition. Because the SA node is going to tell me that I have atrial conduction, and really what I'm looking for is P waves. So having P waves is going to tell me that I have conduction above the ventricles. And so my first question is, do I have P waves? And if we look here, we do have P waves. My next question is, are my P waves marching out? Do they happen regularly? And if we had some calipers and we measured these out, we would find that they do. The next thing when I'm looking at the P wave is I want to know, is it positive or negative deflection? So if we remember with that view of lead 2, with my eyeball down here, anything heading towards my eyeball should be positive. And in here we do have positive P waves. So that tells me that this conduction is flowing from the atria down to the ventricles, which is what we want. Lastly, I want to look at the shape. What we have here is this nice rounded over P wave, which correlates to an SA node firing. I also want to make sure that all of my P waves look like this. So that way I know all of these P waves are coming from the SA node. Now, I may have something of a different shape, like an M shape, could be upside down, maybe pointy, or it could be a combination of all of these. And that could tell me that I have conduction coming from different places in the atria than just the SA node. So I may see this in something like AFib or multifocal atrial tachycardia. The next piece on our conduction pathway is going to be the AV node. And as we know, the AV node is kind of the gatekeeper between the atria and the ventricles. And it's there to kind of slow down that rapid firing of the SA node as it heads down to the ventricles. So the AV node correlates with the PR interval. So when I look at the PR interval, first I want to identify that I actually have a PR interval, or I have a P before my QRS or my R waves. So I have atrial firing prior to my ventricle firing, which I do. Next, I want to make sure that my PR interval is within normal limits. Anything that's larger than 200 milliseconds or 5 little boxes is considered extended. We would see this in first degree AV block, for instance. And here, if we measure it out, this is a nice one here. We have our P, our R here. And we can see we have just over 2 little boxes. So we're within normal limits. And I want to make sure that that's consistent. Does my PR interval change? And briefly scanning over our strip here, we can see it doesn't. So I may have something where our IPR interval gets bigger or smaller that I might see in like a second or third degree AV block. The last stop on our pathway is going to be the ventricles. And what I'm looking at here is the QRS. The first thing I'm going to look at is the width of my QRS. That's important because one of the most dangerous things that can cause a wide QRS is going to be a ventricle rhythm. There's a few other things that can cause it as well, but that's kind of right off the bat, one of the more dangerous ones. So when I'm looking at my QRS, I want to make sure that it's less than 120 milliseconds. And we can see that right here is a good example. We have a nice narrow QRS complex within that 120 milliseconds. Next, I want to look at my R to R. And this is to look at my regularity. And as we can see, if we had some calipers too, we could confirm this. This rhythm appears fairly regular. After that, I'm going to look at my rate. Now, most 4-lead strips will print out a 6-lead strip, a 6-second strip, excuse me. But actually, if we looked at this one closely, we could find that it's a little shy. Because 6 seconds is going to equal 6 sets of 5 big boxes. 5 big boxes being 1 second. But like I said, this one's a little short. So there's another way we can count our rate. Get rid of some of this. And that's to count the space between our R to R. Now, we can only do this with regular rhythms. So the way to do this is find a QRS that is very close to a thick line. And here we have a great example. And we're going to count out the thick lines to the next QRS complex. So this first one would be 300 beats per minute. This next one would be 150, followed by 100, and 75. This kind of lands somewhere in the middle. We would probably say maybe 80, 90, 95-ish. So it's probably around the 85 beats per minute, give or take. And so we know that's within our normal. It's not bradycardic. It's not tachycardic. The next thing I want to look at is my QRS complex positive or negative? We see we kind of have a little bit of a biphasic thing, but the overall direction of the complex is positive. And just like with those P waves we had talked before, that means my conduction is heading down towards my eyeball. So that's what I want to see. So taking it all together, we have positive P waves that have a shape consistent with an SA node firing, happening at a regular rate, going through the AV node with a normal delay, and we're having our P waves happen before our QRSs, and we have a ventricle firing at a normal rate that is also heading down the normal conduction pathway, or we would call this normal sinus. Now, you might be thinking, what about the T wave? For rhythm recognition, the T wave's not very important for the first piece. I like to consider it an additive. So if we had some sort of abnormal T wave, maybe a peak T, we would call this normal sinus with blank, peak T's. These other additives could be things like other ectopy, such as premature conductions like PVCs, escape beats like a junctional escape. So it could be a sinus bradycardia with junctional escape beat. Could also be something such as aberrancy, which would be some sort of conduction delay that we would usually see in a widening of the QRS. So this could be stuff like Wolff-Parkinson's White or bundle branch blocks. And again, we would have something that says normal sinus with bundle branch block, right bundle branch block, left bundle branch block. All right, so these would be additives. So that's all I got. Hope this helps. If you got any questions, let me know. Thanks.